Determining whether each relation defines a function. Well, to think about a function is such that there's one output for every input. So we can't have this repeat of, we can't have different outputs going to the same input. So in other words, in an ordered pair, we can't have the same x value to two different y values. So an example of this would be if I have the set of points 1, 5, 3, 5, and 5, 5. This actually is a function, yes, because there's no repeated x values. If we wanted a second example of this, so I have the set -1, -3, 0, 2, and -1, 6. Notice -1, -1 shows up twice. There is a repeat of x values, so no, this is not a function. On a graph, a way to also think about this is what's called the vertical line test. So in other words, if I have some function, as long as I'm able to take a vertical line at any point and only go through one point on the graph, it is a function. So this one would be considered a function. Something like this, because when any vertical line would go through 2 points on this graph, this would not be a function. And that's what these points are saying. If I have a repeated x value, it would be this case. If I don't have a repeating x, but repeats in y are okay, that just means I got up to the same height at some point, but I didn't have a repeat in the x, so that I would be crossing more than one point.